Welcome to Circuit Valley. I'm Gaurav. Today, in this video, we're going to continue our series of decoding digital communication buses that are present in the embedded environment. So till now, we have covered quite a few protocols and quite a few buses generally you found in an embedded board, generally you found in an embedded environment. We have decoded SPI, I2C, UART, CAN, LIN. We have also decoded a parallel bus and also I2S bus. Today we're going to take a look at a really special bus. I do not think this bus is very common, and its usage and this kind of documentation demonstrating the capability of this bus have not been published on internet till now. So we are going to take a look. MIL standard 1535. It's also called MIL-BUS. Setup remains same. On the right side you have RTB204 300 MHz basic oscilloscope. Although modern oscilloscope, this oscilloscope is not capable of decoding MIL. In the middle you have a behemoth of oscilloscope MSOS 804A. This is 8 GHz 20 gigasample per second oscilloscope. It can decode MIL-1535 as well. On the left side you have MDO3000, MDO3054 500 MHz oscilloscope. This can also decode MIL standard 1535. To be able to generate these signals, we are going to use a really special board. This board is a demonstration board for MDO3000 and it generates all the signals possibly you can imagine. So let's take a look at the hardware itself. So this is our board and our MIL signal is getting generated on these headers, and I have connected two of my oscilloscope, my MDO3000 and MSOS 804A, and both are looking at MIL signal. This board is very capable board. It can generate every protocol you can imagine. To know more about this board, if you watch my first video in the series, I have detailed documentation available. What does this board is capable of? So let's get started with my MDO3000 and we will see how does the content of MIL standard 1535 looks like. So this is how the scope looks with the two MIL signals. And let me zoom in. You will be viewing the web overview overlaid onto the video so that you have better contrast. And let's take a look at the signal itself. And how does it look? We'll do a single trigger because it's too flickery. And this is how the signal looks. It's some kind of differential signal with the ideal state being 0 and the signal pulling low and high. Both, sometimes it goes up, sometimes goes down, below 0 and above 0, and there is an inverted channel also available. So let us trigger and we'll see how can we find a good trigger condition for it. As I said, digital buses are very easy to trigger on, and we just need to trigger on this dead time, and dead time can be definitely be measured. It is delta is around 29 milliseconds or something like that. We will set up a pulse trigger on 29 milliseconds. First of all, we need normal, and second we need a pulse trigger. You can choose both of them because you see this signal is really special. I'll let it to choose positive signal, positive pulse, because signal is really special. It goes positive and both negative both, so we can happily choose whatever we want. And just enter 29 millisecond. Okay, now it should trigger quite stably. Now you see it's triggering and signal is also absolutely stable. So that's how you easily stabilize a signal or packetized signal. So bus we have, and now we're supposed to set up a bus decode. Okay, so I have already selected MIL-1535 and threshold high need to be set according to high, and threshold low need to be set according to low. Okay, and response time, minimum, maximum, everything is correct. Level is correct. Bus display, event table, everything is correct. So you see our MIL-STD-1535 packet is displayed on the screen, and we are decoding it very, very nicely and stably. If you want, I can show you zoomed in. It's the same packet being repeated all the time. Okay, so it started with E45D, some command and return, subaddress, word count, and stuff like that. Let's look at the bus table so that we can analyze it a little bit better. Event table. Okay, so this is the event table of our MIL-1535, and you see command and data, everything being repeated over and over. And so as easy as that, we are able to decode the bus. Let's see if what kind of pulses or what kind of bus trigger we can set up there. Just to show you that you can set up a bus trigger on sync, on command, on status or data, on time and error. these kind of triggers are available to you. Let's set back to the width trigger one more time so that we see signal more stably. So yeah, signal is absolutely stable, absolutely nicely decoded and displayed on our MDO3000. So we are done with MDO3000. We are able to decode another MIL-1535. Now we'll go to my MSOS 804A. So now we are looking at my MSOS 804A. I have also overlaid the web view of this oscilloscope as well so that you can see better a little bit. And we are looking at the signal itself. You see, let me do a single shot capture because it's not very stable. So it's same bus, differential signal. Let me move it a bit. So it's exactly the same bus, differential signal, everything is overlaid on top of one another and it's running absolutely fine. To stabilize the signal, we are supposed to set a trigger. Appropriate trigger for this kind of stuff is a pulse width trigger, and you see this on yellow channel. This packet is having a negative going pulse from here to there, and we'll set up a trigger on that. Trigger, pulse width, and it's supposed to be a negative going pulse for 30 milliseconds, and we have already set it appropriately. So that's it. And I'll set it to trigger mode, and now you should see an absolutely stable trigger. It's absolutely wonderful, absolutely stable, absolutely nice trigger. Okay, so now what do we do? So now that we have a stable trigger, I'll set up a protocol decode. Now I'll go to setup menu, protocol decode, MIL-1535, positive signal on my PCB right now connected to channel number 3, and I'll do turn on, and rest of the stuff it can find out itself. You don't have to do anything at all. Okay, so you see that data word, command word, everything is visible. Okay, and everything is as expected the way we are sending. And if you want to take a look in the zoom view, I can go in the packet itself and I'll show you. We do single capture. So command and data word, everything is being displayed perfectly nicely. So we have also successfully decoded MIL-1535 with this oscilloscope. Let's see what kind of trigger features it expects. So let's see what kind of trigger possibility it has on the MIL-1535 bus. Protocol, it has already selected MIL-1535. So we can select on command, status word, data word, specific event, errors, and we can select all the parity and stuff like that. So it also allows you to trigger nicely on this waveform. So we have also decoded one more protocol now. Still now we have covered SPI, I2C, UART, CAN, LIN, parallel buses, and digital audio signals. So in this ongoing series, this is my 7th part. There will be more videos coming soon. Keep watching, and there will be video coming about USB, MIPI, which is used for camera and displays in the cell phone. We will also try to go with the PCI, and we are also going to do some advanced stuff with PCI, USB 2.0. You can visit my website www.circuitvalley.com for advanced FPGA related projects.